Oh my God, is that Lex? It's Astrostetics. Let's get it, baby. Y'all, today we gonna get into some amazing things, and Astrostetics is gonna be our reference for today. And the topic for today is tropical sidereal astrology. Now, in Astrostetics, it doesn't matter what you use because in Astrostetics we say that the math is over the mythos. Well, the math and the mythos are aligned synchronistically. So when we understand things mathematically and when we can grasp the physics around why things happen, we can easily understand any mythos and a lot of superstitious quasi ideologies. We'll see that when we just understand the math and the physics around them, they're easily explained. And it'll make more sense as to why the ancestors would create stories to represent the physics of what's really happening. So let's go to page 191 of Astrostetics. When we go to page 191 of Astrostetics, the position of the vernal equinox changes every year. What is the vernal equinox, right? We're going to explain that. The position of the vernal equinox changes every year, and sidereal astrology measures this difference naturally. To sidereal astrologers, tropical astrology is called the moving zodiac. That's trippy because the tropical system is fixed, with 0 degrees Aries being the point of origin. Now, throughout the duration of the video, I'm going to explain all of this, and through the great source in Astrostetics, we'll be able to simplify a lot of these things that go on. Now, let's begin with a circle, all right? And now, when it comes to the circle, we know that the Earth is not a perfect circle, guys. The Earth is an oblate spheroid. What does an oblate spheroid mean? An oblate spheroid, let's say you have a ball and we squish it, right? Let's say we take a ball and we squish it, right? Now let me show you something. When we take the Earth and we insert a disc into the middle of the Earth, we take a plane. We take a plane and we jet in Astrostetics. Listen, y'all, in Astrostetics, we take a plane and we jam it into the middle of the Earth. And then we have the equator, all right? And y'all, I know y'all familiar with the equator. When the sun is in alignment with the equator, day and night are equal, or we have the even hour of daylight and twilight as well. And with this is showing you the importance of balance. Well, think about the word equinox. When something is equal to each other, they share a mutual point of relativity. So remember, y'all, we jammed a flat plane into the middle of the Earth, all right? And then this flat plane creates our hemispheres, y'all. So when we split this plane, we have the northern hemisphere and the southern hemisphere, right? But now this is the other thing. We have the North Pole in the northern hemisphere, and we have the South Pole in the southern hemisphere, right? Now what happens is this. We have this thing called an axial tilt. We have the axial tilt, and in reference to the axial tilt, we draw another line, and the Earth and the axial tilt, they have an obliquity of around 23 degrees, all right? And this means that when this is the angle of separation between the equatorial plane and the actual tilt that the Earth orbits around the sun. And what you'll notice when you tap in with more astronomy, you'll notice that all of the planets have a tilt. And listen, y'all, this is an interesting fun fact. Venus and Uranus are the most tilted out of all the planets. Venus is tilted and it orbits the sun in the opposite direction as the other planets. And yeah, this is real astronomy, and this is really what goes on. All right. So when we look at the axial tilt is separated on the equatorial plane from with a deviation of 23.5 degrees, right? And this axial tilt here, we have the North Pole and we have the South Pole. Now look, remember we was talking about the term oblateness, right? Because we were saying that the Earth is an oblate spheroid. This means that at the North Pole and the South Pole, there is a flattening going on. So for geocentric purposes, right? For geocentric purposes, we're supposedly saying that, let's say that the Earth is at the center of the universe, right? The when you go to the North Pole, it's flat up there, and we know this because the Earth is an oblate spheroid, which means that it's flat at the poles, it's flat up here, it's flat down here, and in the middle, as we go towards the equator, there is an expansion that goes on around the equatorial belt. And this is what we will call in science the equatorial bulge. All right. So all planets have an equatorial bulge because planets orbit around stars. And in astrostetics, we know that there are differences between stars and planets. Planets orbit around stars, and stars process hydrogen and helium, and they can create solar and other forms of energy. But this is the hydrogen, right? Y'all know the hydrogen, solar energy. This is because stars process solar energy. And you know, this is another fun fact. The planet Jupiter, which is the biggest planet in our solar system, and the natural ruler of Sagittarius and Pisces, Jupiter and the sun, Jupiter was on its way to becoming a star. And if you find Jupiter in the night sky, Jupiter is a big bright guy. All right. So make sure y'all shout out Jupiter, the beautiful jovial one. All right. So y'all, we know that the Earth is not a spinning ball, but the Earth is an oblate spheroid. All right. And because the Earth is an oblate spheroid, it is flat at the poles, and as you go towards the equator, it expands. And we'll also get into that in the video. And y'all, listen, all of this relates with astrology. All of this relates with astronomy. The equator, right? When we look at the equator, we have the North Pole, South Pole. We know that at the North Pole, there's the star Polaris, right? So Polaris is the North Pole star. When we go to the South Pole star is called Sigma Octantis. All right. The Southern Pole star is called Sigma Octantis. The Northern Pole star is Polaris, and then the Southern Pole star is Sigma Octantis. All right. And now, when we go towards the equator, we have the expansion and we have the equatorial bulge. And when we go to the top where the poles are, if you look at certain reference points, they'll have Polaris as the northern pole star. All right. And then you know that in a whole other school of thought, Polaris is the star that our sun orbits around. But we know that our sun orbits around the galactic center, which is located in Sagittarius, is the galactic center. And notice that the arrow is pointing there. All right. So it's pretty interesting how this thing works symbolically wise.
In Astrostetics, we know that the equator and the meridian, the prime meridian, they run perpendicular to one another.
Now look, we have the equator right here. Then y'all, this is important. We have the Tropic of Cancer. All right. Now y'all, now we got to talk about the tropics, because we're talking about tropical astrology here, right? What is tropical astrology? Well, think about it. What is a tropical island? When you want to go to the tropics, you want to put your feet up on a beach, right? You want to kick your feet up. You want to enjoy that tropical climate. Well, the tropics, it breaks down to the word turning point. So when the sun is by the tropical point, there is a deviation in the direction of the sun. Now we're going to explain this. Here we have the equator, right, in the middle. Then we have the Tropic of Cancer. Then we have the Arctic Circle. Then we have the Northern Pole Circle. All right? And we see this when we go north from the equator. All right? So if you took the Earth and put a flat disk, a flat plane in the middle of the Earth, when you go up, when you go 23 degrees up, you will go to the Tropic of Cancer. Then when you go 66 degrees up, you're going to be at the Arctic Tropic. Then, well, I don't know if they call it the Arctic Tropic, but you're going to be in the Arctic zone, all right? And these are degrees of latitude, all right? So then when you go 66 degrees up, you hit the Arctic Circle, then you go to the Northern Circle, all right? Then, now, when we go back to the equator, all right, when we go down here, now when we go 23 degrees down, y'all, remember in math class, what you do on one side, you do to the other, right? Yeah, right? Now, the equator, we got but when we go below the equator, we have the tropic, no, we have the Tropic of Capricorn. Then we have the Antarctic Circle. Then when we go down, we have the Southern Pole Circle. All right? But now look, when we're talking about tropical astrology, we're only focusing on here. We're focusing on the tropical zone, because when the sun goes to 23 degrees Cancer, the sun goes back down. Now let's explain this, and make sure y'all check the YouTube, because we have other videos on this. When the sun goes by the equator, right, we have the vernal equinox. So when the sun is by the equator, we have vernal equinox. And in tropical astrology and Vedic astrology, this is what you will call 0 degrees Aries. This would really be when the sun is here by the equator. Now remember, y'all, 23 degrees Cancer, the equator, and 23 degrees Capricorn, these are important to remember because these are the tropical zones. So let me explain this. Once again, 0 degrees Aries is when the sun is by the equator. And we have a equal amount of daylight and twilight at the equator. And this would be when the sun and the earth, there's this invisible line between them. And when these lines are in a way running through each other, this is when we have the equinox. Now, this line that we would say, its focus would be the tropical zone, because the tropical zone, y'all remember, this is the tropical. This is the island man, the island gal them, which is the tropical zone, and this is also the focus of the equator. And this matters, and it's relative to us terrestrially. Now, yeah, let's keep breaking this down. When the sun is and the earth is in alignment from the perspective of the equator, we have the autumn, the vernal equinox, right? And in our tropical measurement, this would be 0 degrees Aries, and in our calendrical system, March 21st, sometimes March 22nd. All right, and look, y'all know I'm Pisces, right? Y'all know that's around where my birthday is. All right. So look, when we have this, we have the vernal equinox, and then when 6 months later, the sun goes by the autumn equinox. Now, the sun and the earth, in a way, the equinoxes are the same. There are multiple differences. One of the main differences is that the sun is in Libra. So when the sun is in Libra, we have the autumnal equinox, and when the sun is in Aries, we have the vernal equinox in our tropical system. All right? And remember that tropical astrology is based off of the tropics. And the tropics is the essentially not only a concentration of the sun's heat, but it's also a concentration of the sun's gravity. All right? And this is why around the equator, we have when we split it, remember that disk that plane that we jammed into the middle of the earth? When we separate that, we get the northern hemisphere and we get the southern hemisphere. And when the sun is in Libra, essentially the sun is going down, right? The sun is going downward. So when the sun is in Aries, the sun is going up. And this would make Aries one of the northern constellations if you're in the northern hemisphere. All right. And this also goes into when the sun is in Aries, right? We have when the sun is 0 degrees Aries, we have the vernal equinox. Then 3 months later, or 90 degrees later, because remember, y'all, astrology is all about mathematics, right? So 3 zodiac signs later, or one season later, the sun is going here. The sun is going to the northern tropic of Cancer, and then the sun in the northern hemisphere, this is the highest point that the sun can reach, 23 degrees, which is the tropic of Cancer. Then, yeah, think about it like an elevator or like a solar oscillator. In Astrostetics, we could refer to this as a solar oscillation. All right. Now, when the sun is going up here by the northern tropic of Cancer, the sun is coming downward. And then when it's by the equator, when the sun is in the northern tropic, it's by the tropic of Cancer. And then remember, it descends down. Now the solar oscillator is descending downward, and then when the sun is going down, it goes by the equator again. Or this invisible line that connects the earth and the sun, they are equatorially equivalent. They are running through each other, so they are equatorially equivalent to one another during the equinox. So when the sun 0 degrees Aries, right? This would be the vernal equinox. Then 3 months later, or 90 degrees later, the sun is by the Tropic of Cancer, and then the sun goes back downward. Then 3 months after that, and when the sun is by the Tropic of Cancer, we have the summer solstice. All right. So the summer solstice in the northern hemisphere, this is when the sun is closest to you, and this is when you would have summertime. But then remember, because we have the two different hemispheres, in the southern hemisphere, when we're having summer, in the northern hemisphere, they're having winter. And we know this from math because what happens on one side happens on the other. But of course, when we're dealing with natural forces, the properties of the energies will change. All right? So remember, in the northern hemisphere, when you're having summer, in the southern hemisphere, they're having winter. And in the southern hemisphere, when they're having their summer, we're having our winter. So at the time of this beautiful recording, in the southern hemisphere, they should be getting jiggy out there. It should be their tropical time in a way, or when the solar oscillator is the closest to them relative from their perspective. So yeah, when we're talking about the tropics, right? We know 0 degrees Aries is the vernal equinox, then 90 degrees, then 0 degrees Cancer is the summer solstice, right? And then 3 months after that, the sun is by the equator again, and we have the autumn equinox or the fall equinox. But remember, this is really 6 months later. So remember, if we start from the vernal equinox, 6 months later, yeah, y'all know like that meme, 2 moments later, right? I want y'all to think 3 months later, then 6 months later,
6 months later,
then 9 months later, then 12 years later, or a year later. Yeah, this is how the seasons work, right? So when we're having our when it's our fall season in the northern hemisphere, the sun is by the equator again, but this time the sun is going downward. All right, the sun is going downward now, right? So this is the difference between the vernal equinox and the difference between the autumnal equinox. In one aspect, the sun, the solar oscillator in astrostetics, is going upward like an elevator, and then when the sun is in Libra season, the sun is going, it's descending down. And this is why you see that Libra is represented as the scales, right? Because in a way, it's balancing things out. And when the sun, when it's in Libra in the fall season, we also have an equal amount of day and an equal amount of night at the equator. So listen, in the northern hemisphere, we have our solstice when the sun is farthest away from the earth. Now, you would think that because it's hotter, right? This means that the sun is closer to the earth. That's not the case. In the summertime, the sun is at aphelion, and this is an astronomical term, which means that the sun is at it, and the earth, or when an astronomical body is at aphelion, this means that it's at its farthest point away from the gravitational center of its orbit and the star that it's orbiting. So in the summertime, the sun and the earth, they are at aphelion, which means that the sun and the earth are at their farthest distance apart. However, we have our summer. Now, literally, this doesn't make sense. And y'all, this is why in astrostetics, we know that astrology is governed by Aquarius, because this is unorthodox. This doesn't make any sense to the literal mind. But when we break it down, because Aquarius deals with I know. So this is how we know that now we got to get mathematical with this, right? So when the sun is in aphelion with the earth, they're at their farthest distance apart. All right. But in the northern hemisphere, we're having our version of summer because the sun is at its closest point to the northern hemisphere when it is, and it's also at its highest point when it is in the Tropic of Cancer. And this is also an angular relationship. When the sun is at 23 degrees, and this when the sun is at 23 degrees and it's in the northern hemisphere, and when it's in the northern constellations from an equatorial point of view, this also is when the sun's rays are directly hitting that portion of the earth. So in the wintertime, the concentration of the sun's rays, they're angled away from the surface of the planet. So what we're saying is that this is an angular relationship with the sun and the earth. That's what your seasons are. Your seasons in astrostetics, we look at them as an angular relationship between the sun and the earth. And this is measured consistently when we deal with the tropics. So now y'all should be beginning to understand that this is the main difference between tropical astrology and sidereal astrology. This whole thing, what we've been explaining, is the tropics, because in astrostetics we look at this as a terrestrial thing, right? So that means that it becomes geocentric. When you're looking at the natal chart in astrostetics, we look at it as the geocentric relationship between you being the native and the sun and the other planets when you were born. And this is why we will call the natal chart a 2D snapshot of the native when they was born. But this is really an astronomical measurement of your relationship with the heavens at the time that you were born. And this is why they will call a natal chart and you being the nativity. That's why they would use those two terms. But y'all, this, what we're talking about, this is why in astrostetics, we call tropical astrology in a way terrestrial astrology. Your tropical chart is the terrestrial relationship between you and the heavens. But the tropics is a measure, it focuses on the gravitational barycenter between the sun and the earth. Now, what do I mean by this? It's like if you got if you get two magnets, just playing around with them, you'll notice that when you put them together, when they are equivalent to each other, they cancel each other out. But when they're at a little bit of a distance apart, in a way, you can kind of feel the force of them a little bit more. But if you put them together, they're canceling each other out, or they equal each other. All right. All of this stuff, make sure you pick up my book, Astrostetics. All right. Like, yeah, we're not just making this up. All of this is in my book, Astrostetics, and it's in the description. Make sure y'all pick it up right now. All right. So let's continue. So now we know that tropical astrology is a measurement between the gravitational barycenter of the sun and the earth. So now you should begin to know that the sun and the earth, the earth doesn't necessarily orbit around the sun. They orbit around their equivalent barycenter. And on the earth, that barycenter would be equivalent to the tropics. Listen, y'all, let me run that back. On the earth, that that barycenter would be the tropics. And this is why the ecliptic is projected from the equator. So y'all know that we have the north, the celestial pole. All right. So we have the equator, we have the ecliptic, and then when we project the equator into the sky, this becomes the celestial equator. Now, when we're talking about sidereal, right? Now let me read page 191 out of Astrostetics again, and we gonna turn it up and get into some sidereal. Yeah. If you watching this video, make sure y'all subscribe. Like y'all never seen nothing like this, man. Y'all never seen nothing like this, man. Come on. Make sure y'all like the video, y'all. We so lit. We so turned up right now. Make sure y'all like the video, man. Come on. Alright? We having a great time. I know I'm having a great time. I hope you are too. Alright? So yeah, let's read page 191 out of Astrostetics again. The position of the vernal equinox changes every year, and sidereal measures this difference naturally. Now, let's stop right there. The position of the vernal equinox changes every year in sidereal astrology. Because sidereal astrology, what is sidereal or sidereal? Sidereal is a measurement of the stars. So listen, you guys see how this is a breakdown of our seasons in relationship to the tropics. All right. So let's just do this one more time. We know that the equator or 0 degrees, this is the equator. Then when we go up, this is the Tropic of Cancer. Then when the sun comes back down, when the solar oscillator goes back down, we have the fall season. Then the sun continues to go down, and then we have the Tropic of Capricorn. All right, and then the sun goes back up, and then we have the spring season again, right? And that is a brief synopsis that explains our seasons. All right, but now remember, we have the Antarctic Circle. All right, don't forget in the beginning of the video we have 7 planes of latitude, but the tropical zone is where the sun and the earth's gravitational relationship resides the most. All right, so this is why tropical astrology focuses on the tropical zone. And then this is really what matters. This is essentially what matters. And this is why tropical astrology is so relative, because it is focusing on a mathematical, gravitational, relative relationship between you and the earth and the sun. All right. So yeah, make sure y'all pick up Astrostetics, and we go into this a lot more. All right. Let's get in the sidereal. Y'all be calling it sidereal. Y'all got a bunch of different things going on. Y'all know that, right? Y'all know y'all got it's a lot of mix up going over there. All right, but let's get into this. I'm just playing. When we're dealing with sidereal is a measurement of the relationship between the Earth and the fixed stars. Now, this could also be a measurement of arbitrary points in space, because when we're dealing with the tropics, essentially the tropics is a focus of the sun and the earth. But when we're dealing with sidereal, this is a measurement between the earth and points in space. And this is why, if you was to look at your tropical natal chart or your sidereal chart, you'll notice that there is a difference. There are degrees of separation between your tropical chart and your sidereal chart, or your even your Vedic astrology chart. And this is because your Vedic chart is focused around sidereal measurements. And when we're talking about sidereal measurements, We're talking about stars. All right. So when we're dealing with stars, stars are sidereal, and if you was to measure stars in the actual sky, because y'all know, like, even though we like to do astrology and we like to look at computers all the time, we know that we actually should look at the stars. Like, if you have a window in your house, you should probably be looking at the stars. And if you was to look at the stars, you would notice that every day they drift, right? So every day, if you was to look at a star at the same time every day, you would notice that it'll drift every time. And this is why in Astrostetics we said that the position of the vernal equinox changes every year, and sidereal measures this difference naturally. Now what it is it actually changes every day. It changes every second. And this is why sidereal, it changes consistently. And if you really look at it, you'll notice a lot of variations there. But when we focus on the tropical zone, we have a more sophisticated element of consistency. And this is why the tropical zone, the sun is more consistent. When things are solar based, they are consistent, right? Like, if you know any holidays or holy days that are solar based, they won't ever really change, because in astrostetics, we know that the sun never deviates off of its course. So essentially, these zodiac signs, they are always there because the sun never deviates from its terrestrial path. All right. But when you measure things in sidereal, just like how we said that if you was to look at a point in space, it will change every day, right? So if you was to go outside tonight and look at a star, it would be in a different spot the next day. And if you was to do this throughout the course of a year, it would eventually add up, because sidereal time is different than terrestrial time. Throughout the year, that position of that star will change. And essentially, this is the difference between sidereal time and tropical. All right? Sidereal is measuring the relationship between any arbitrary point in space. But when we're dealing with tropical astrology, or Sayana, right? The Sayana, this would be a consistent measurement of the gravitational relationship between the sun and the earth. And this is why in astrostetics we say that tropical astrology is relative. Now, when it comes to sidereal or any forms of astrology that uses sidereal measurements, they are what is actually there. So if you was to look at your tropical astrology chart, you wouldn't notice, you would be like, wait, the way the heavens was when you was born, they don't look like that. But you remember that drift that we was talking about that happens every day, right? When you add that up, or when you subtract that amount of precession, that would be your sidereal chart. Your sidereal chart is showing you the heavens as it was when you was actually born, or the apparent relationship between you and the heavens when you was born. But then tropical astrology measures the relationship between you and the relative gravitational center of the sun and the earth. This is like with tropical astrology, with sidereal astrology, every on the vernal equinox, the vernal equinox, if we was to actually look at where the sun was during the vernal equinox, the sun would be in Pisces. But when we're this is why we say that, yeah, we're and essentially we're in the age of Pisces when we look at the sun, where it is on the actual vernal equinox, it's in Pisces. And what makes an astronomical age, this is where we're measuring time from. So when we look at where the sun is, right, if we don't use no technological instruments, if we don't use any mechanical type of things to assist us, the sun would be in Pisces, y'all. All right? But when we know that the equinoxes, they're measured from where the sun is on high noon, right? Now, yeah, we're gonna go into take it a little bit deeper. This is the equinoxes. This is 12 p.m. All right. So the equinoxes are measured. Where is the sun at 12 p.m. when it's at its highest point on the equinox? All right. So when we have an equal amount of daylight and twilight or night at the equator, where is the sun at that time? And when we look outside in the sky, where the sun is at 12 p.m. high noon on the equinox, the sun will literally be in Pisces. If we use sidereal measurements. But then when we measure this thing from high noon, right, when the sun is at its highest point, that's when the sun is by the midheaven. Or this is when the sun is in the southern part of the sky. So in Astrostetics, y'all, this is why we tell astrologers the midheaven is not the top of the chart, right? The midheaven is the southern part of the sky. And in Astrostetics, we pay attention to this because this is where time is measured from. Time is measured from when the sun is at its highest point in the night sky. All right? And when we measure where are these things the most powerful, we would have a nice amount of axial precession because we're essentially looking at where is the sun in relationship to the disk. The disk, y'all know that the surface of the sun is not the hottest part. The surface of the sun is not the hottest part, y'all. The surface of the sun is the sun's corona is a million times hotter than the actual surface of the sun. So if we had the sun, I know this look crazy, but if we was to look at the sun, right, the surface of the sun is not the hottest part. The hottest, most intense part is the coronasphere. When we look at the tropical zone of the coronasphere is concentrated around the equator. And this is why we have the equatorial bulge by the equator, because this is the center point of mass between the sun and the earth. But when we're dealing with sidereal measurements, we need sidereal measurements to get tropical measurements. This is why we tell astrologers, do not try to get into this weird beef between them. Like, y'all notice, we didn't do tropical versus sidereal because you need sidereal measurements to calculate tropical measurements. And you need tropical measurements to convert to sidereal measurements. So because we're measuring this off where the sun is, look, over the natural course of a day, there's different ways to measure a day. We could measure a day as 4 portions of 360 minutes. 6 hours is 360 minutes, right? Then when we add another 12 hours, that's 720 minutes, right? Then when we add another 6 hours, that's 1080 minutes, right? Then when we add another 6 hours to 18 hours, that is 24 hours, and that is a full day. But as the sun is going around the earth, remember, y'all, the vernal equinox is where is the sun at its highest point when day and night are at equal lengths at the equator. That happens at 12, at around 12, when the sun is at its highest point. Y'all, this is literally explaining exactly what sidereal and tropical astrology is, what tropical astrology is about. Because then, when you want to actually look into a chart, you're going to actually come across sidereal and tropical. And this is why both of these measurements intertwine with each other. When you want to actually factor in how did the heavens look when you was born, sidereal is going to show you exactly what the heavens were like. When you factor in that the gravitational point of the tropical zone, and you account for the sun and the gravitational relationship between the earth and the sun. Whereas when you're dealing with sidereal, this is why with sidereal, you can almost use any point. When you're dealing with the prime meridian, you can have a prime meridian anywhere. You don't have to have a prime meridian in Greenwich. Is the prime meridian, right? Look, Greenwich is the prime meridian, right? It's not the only meridian, but it is a reference point, right? So our equinoxes and our solstices, all they are different measurement points, right? When we compact the universe and the relationship between the sun and the earth, it would always be centered around the tropical zone, because the tropical zone, there's an expansion on the earth. And this is why if you even go to the equator, there's a difference in time. So as you go towards the North Pole, or as you go above the tropics, with Polaris, it's like somebody stepped on it because it doesn't move, right? Polaris, there are stars that orbit around Polaris, right? But the pole stars, the stars around the pole stars are called circumpolar stars, right? And circumpolar stars, they orbit a bit slower, whereas the star Polaris is a fixed star, right? But this is what separates the North Star from the sun and the other stars. So in a way, we have 3 kinds of stars. We have the pole stars, then we have the sun, or the sun is the closest. The sun is the closest star to us, right? And it has the most mass and gravity in the solar system. So look, and y'all, we about to end this out. When we look at an astronomical unit, what is an astronomical unit? An astronomical unit is y'all know that movie like Journey to the Center of the Earth? An astronomical unit is a measurement from the center of the Earth to the sun, which is 93 million miles, right? So when y'all hear them talking about 93 million miles, 93 million miles equals 1 AU, right? But when you actually look up a AU, which is a term for an astronomical unit, an AU essentially is a measure between the center where it matters, or the equatorial zone or the tropical zone, and that line between the sun. All right, and off this, we know that all the planets have equinoxes, and all of the planets happen. All of the planets have their solstices and equinoxes, right? So different planets, they have different weather systems. They have different weather changes, and yeah, this is real astrology, real astronomy right here. But yeah, this is really how astrology works. Without all of this, you get no natal chart. All right. So yeah, make sure y'all like the video. Make sure y'all subscribe. Make sure y'all turn it up. And yeah, this is one of the best videos on astrology on the internet. All right. Make sure y'all subscribe and turn it up. All right. I had a great time doing this. Make sure y'all pick up a copy of my book, Astrostetics. It's 500 pages. Make sure y'all check it out. And make sure y'all check out Revolution of the Monarch. Make sure y'all check out revolutionofamonarch.com and pick up a hat, pick up some clothes, pick up some gear, all right, and let them know you there. All right, shout out to them, and make sure y'all like and share and subscribe to this video. All right, it's Lex. Yeah.